In this video, we're going to talk about functions and how we go about solving them. And this is in the ACT category of functions themselves. So when we're talking about a function, this gives us a relationship where for every input, there is exactly one output. And there are a couple of tests we can do to see if a relation is a function. And we can use this if we have a graph of the function. And what we're going to do is if you're able to take that graph of the function and draw a vertical line through the graph, and if the vertical line only intersects the graph at one point, that is a function. If when you draw a vertical line, you can intersect the graph at more than one point, that is not a function. So let's look at an example of a couple of graphs. If we have this graph here, it is a parabola, and we look at where we could draw a vertical line. We could draw it here almost at the x equals 2 point. We could also do one over here at -1. Anywhere we draw a vertical line, we're only going to intersect this graph at one point. So yes, this graph is a function. Now take a look at this graph here on the right. If we draw a vertical line here at x equals 5, we cross the graph, we intersect the graph at 2 points. So with the vertical line test, we're able to say no, this graph is not a function. So a function f of x can be written with other terms other than f. You don't always just see f of x. You may see h of x or g of x or some written in some other way. It doesn't just have to be an f. And the term f of x, that stands for function written in terms of x. If we have h of x, that's the function h written in terms of x. You could have g of y, the function g in terms of y. So the x and the y in these cases are the variables. But a lot of times, when you see f of x, if you will also think f of x as y, that may help you in terms of if you're having to do any kind of graphs or that sort of thing. So what we have here, if you're given f of x equals x plus 3, in your mind, you could also think that's similar to writing y equals x plus 3, if you're graphing or if you're solving, that sort of thing. So now when we get to actually solving functions, you can find x in the expression and plug in the value for x. That's if we're given f of x, and maybe we need to find something, in this case, like f of 3. They've given us the definition of f of x to be x plus 6 and say find f of 3. So we're going to take that 3, plug it into our function, 3 plus 6, and that gives us 9. We're just plugging in that value. This is function composition. It's f of g of x. And what that means is we're going to start almost on the inside with the g of x, find the g of x, then we're going to plug that in to f of x. We work inward and then go outward. So here's our example. If we're given a definition of what f of x is, it's 2x plus 1, and we know that g of x is x squared plus 2, we want to find f of g of 2. So the first step, inside, we're going to find what g of 2 is. That means take g of x, everywhere there's an x, we're going to plug in a 2. And when we do that, we get g of 2 is equal to 6. In place of the g of 2, we're going to plug in 6, what we just found for g of 2 to be. We'll go to the f function. Everywhere there's an x, we plug in 6. And when we do that, we get 13. So the final answer of this f of g of x is 13. Let's take a look at this ACT type question. Work the question here for yourself and come back and we'll work it together. The question says, given the function g of x equals x cubed plus 4x minus 1, what is g of -2? So what we're going to want to do is everywhere there's an x in g of x, we're going to plug in a -2. And when we do that, we watch our raising our negative 2 to the third power, we pay attention to our negative signs, and we're going to get a value of g of negative 2 is equal to negative 17, which is answer choice A.